So here we discussed about the file system. Now, when you take this file system, mainly that is what is the hard disk or secondary storage. Now, remember when you take this hard disk or secondary storage, it has kind of concentric circle or as a disk. This is a disk actually, which has the circle like this. And we divide this into circle, we call them as a track. We call them as okay. So we have concentric circles like this. We call them as a track. We call them as a track. Then we divide this into sectors like we divide this into sectors like we call them as sectors. Okay, we call them as sectors. Then we can take 2 or 3 sectors together. We call that as a cluster. We call that as together. We call that as a cluster. Or sometimes we call this as a block. Or sometimes we call as a cluster. One of the names. So this 2 sectors together, or 3 sectors together, we call as a cluster or block. Okay, just keep in mind. Initially, we have the tracks and we have the sectors, and 2 or more sectors together, we call as a cluster or we call as a block. So that's the initial thing you must remember. Okay, we divide this into tracks and sectors, and collection of sectors together we call as a block or cluster. In general, this block size, remember in general, the block size is 512 bytes. In general, remember one block size is how much? 512 bytes. Okay. So we divide initially concentric circles, we call them as the tracks, and we divide into segments, we call as sectors. And once you combine multiple sectors together, we call them as a cluster or block. So in general, when you do the I/O operations with the hard disk, we do the work with the blocks. So in general, one block size is 512 bytes. One block is how much? 512 bytes. So මතක තියාගන්න මේ hard disk එක කියන්නේ මේක අපි මේ වගේ concentric circles වලට බෙදනවා. එතකොට මේ circle sectors වලට බෙදනවා. එතකොට මේ වගේ sectors දෙකක් හෝ තුනක් එකතු කරාම අපි ඒකට කියනවා block එකක් කියලා. ඒක වන්දා cluster එකක් කියලා. එතකොට අපි මේකේ read write කරන්නේ IO operations කරන්නේ hard disk එකත් එක්ක හැමතිස්සෙම blocks. So one block size සාමාන්‍ය අපි ගන්නේ 512 bytes. හැබැයි වෙනස් වෙන්න පුළුවන්. මේ සාමාන්‍ය විභාගයේදී එහෙම නැත්නම් ගණන් වලදී අපි ගන්න එක block එකක් 512 bytes කියලා. ඒතර අපි IO operations කරන්නේ blocks by blocks. So one block is how much? 512 bytes. That is the one you remember. So when you do the IO operation, we do the IO operation with the blocks. So therefore, we do the IO operation as 512 bytes blocks. So then when you are doing the calculation in exams, just remember we need to do that calculation using the blocks. So what an exam එකේදී ගණන් හදද්දී අපි IO operations හැමතිස්සෙම කරන්නේ blocks විදිහට මතක තියාගන්න. Block කීයක් ඕනද කියන එක තමයි අපිට ගණනය කරන්න තියෙන්නේ. So then in general, the hard disk, then you can look like, so you can think hard disk is something like this. This is a physical view, but when you are doing the calculation or operations, you can think this hard disk is a collection of blocks. So then we can see the hard disk something like this. It has a collection of blocks like this, and we number these blocks. If they start from 0. So 0, 1, 2, 3, 4, like that. So then you can think the hard disk has a collection of blocks like this. And each block is how much? 512 bytes. Then you can have block number 5, 6, 7, 8, 9, 10, like you can number them. And we can take this one block is in general, how much the size 512 bytes. So then always think your hard disk look like this. It has a collection of blocks, numbered from 0, 1, 2, 3, 4, and then we do the IO operation as blocks by blocks. This is how you should visualize the hard disk. Previously, I have done the actual view, but this is a logical view. You should understand how hard disks look like. So, මතින් hard disk එක ගණන් හදද්දී අපි මේ විදිහට තමයි හිතන්නේ. මේක තමයි blocks වල එකතුවක් තියෙනවා කියලා තමයි හිතන්නේ. හැම බ්ලොක් එකක්ම නම්බර් එකක් තියෙනවා බිඳුවෙන් තමයි පටන් ගන්න. So like IO operations කරන්නේ මේ blocks by blocks තමයි IO operations කරන්නේ යන්නේ මතක තියාගන්න. So this is another thing you should remember. Now here you may get the questions for the exams like this. Now assume if you are given the questions like file size is 2000 bytes. The file size is 2000 bytes. Then you are asking how many blocks? How many blocks must be allocated? Must be allocated for a file. For the file. And what is the internal fragmentation? Internal fragmentation size. Now, this is how you get the exam paper questions. There are some questions like this in the level paper actually. Now here what is the question? File size is 2000 bytes. And how many blocks must be allocated for the file? What is the internal fragmentation size? If the block size is 512 bytes. The block size is 512. Then how do you do the calculation?
Now, then 3 blocks now, sir.
Sorry?
Then 3 blocks, we have to, for 2000 bytes, we can take 3 blocks now, sir. We can't take 4 blocks now, right?
No, I didn't hear clearly. Can you tell me again?
The file size is 2000 bytes now, sir. But if you take 4 blocks means it will extend out 2000 bytes now, sir.
Yes, now file size is actually 2000 bytes. Now the block size is 512 bytes. Yes. Now the question is you're asking how many blocks should be allocated for this. And again the file size, if you anything like that, what is the internal fragmentation? So we can easily do it now. The file size 2000 bytes. Now the block size is 512. Then you can see how many blocks are necessary. 3 blocks are not enough actually, because if you multiply 512 by 3, so
1536.
Yeah, if it is 386, 3000 miles, this is not enough. Now you have to go to the 4 blocks, right? 4 blocks.
4 blocks will extend, sir.
420. Now you get how much? 2040. That means you have to allocate how many blocks? 4 blocks. Is it clear?
But it's extending now, sir, over 2000.
Huh?
But it's extending now, sir, over
Yeah,
2000 bytes.
yeah, that's the thing actually. Now, when you allocate the 4 blocks, what happened? When you allocate the 4 blocks, you can see here. We have allocated 4 blocks, then you can see it is 2048. Then you can see this will be used entirely, this will be used entirely, this will be used entirely, but in the last one, you can see it used only 2000, there's the remaining part 48. It is additional. Now that is what we call the internal fragment. That is what we call. Is that clear?
Yes, sir.
That is the additional part which is remaining, which cannot be used by anyone, which is a wasting actually, which is we call internal fragmentation.
We have to take it like 4 tunnels, sir, from the third block.
Third block?
We should take like half now, sir. Half for the below 2000 bytes.
Some amount will be utilized, 48 will be remaining. That 48 actually additional, which cannot be used by anyone. It's a wasting, that is what we call internal fragmentation.
Okay, sir.
So that's what happened here. Now the file size 2000 bytes. Then we have allocated 4 blocks. There is an additional amount, which is we call as what? Internal fragmentation. Okay?
Yes, sir.
Okay, sir.
ඒකේ ඔයගොල්ලෝ පැහැදිලි වෙන්න මේකේ blocks 4ක් අපිට දෙන්න වෙනවා. It is 2000 bytes. But when we allocate the 4 blocks, 4ක් අපිට වැඩි කරේනවා 48. That is equal as internal fragmentation. අභ්‍යන්තර කන්දරය. That's a wasting. Now this is how you get the exam paper question. Some question you get like this. Then you must be able to calculate like this. Programming භාවිත මේ වගේ ගණන් දෙනවා මේ ආකාරයට. ඒ වගේ අවස්ථාවක හදන්න පුළුවන් වෙන ඕන blocks කීයක් වෙනවද කොච්චරක් internal fragmentation වලද කියන එක හදන්න පුළුවන් වෙනවා. I think it is clear.
Sir, what's the heading, sir?
Sorry?
What's the heading, sir?
This is file management.
File management. Okay, sir.
Yeah, in OS. Then the next part, you need to understand is actually what we call that as file allocation actually. How do you allocate the files? The blocks for the file. Now we have the blocks in the hard disk. Then how we allocate these blocks for the files? Now when you are doing this allocation, remember there are no pre-allocation strategies. File allocation. Now, when you do this file allocation, there are 3 ways to allocate it. One is for the continuous allocation. Other one is the linked allocation. Other one is the index allocation. Those are the 3 allocation strategies. Continuous allocation, linked allocation, and index allocations. So there are 3 allocation methods. Allocation means we have the blocks in the hard disk. How to allocate these blocks for the files? That is called allocation. So then contiguous allocation, linked allocation, index allocation. Those are 3 allocation strategies. So then we want to study each one, how you can do this allocation. So allocation means we have the blocks in the hard disk, and then how do you allocate these blocks for the files? Which blocks will be allocated for each file, which is we call the allocation methods. So then there are three of them: contiguous allocation, linked allocation, index allocation. These three you have to understand very carefully, because in past papers, all the past papers, actually last 5 years or more than that, all the past papers, there were at least one or two questions from these three. Therefore, you need to understand this one very carefully. Okay?
How many marks, sir? One
Huh?
question.
Sorry?
How many marks? How
It
many marks
depends
for a
actually.
question?
It depends. Sometimes the questions are in the MCQ. Sometimes the questions are structured essay. And sometimes the questions are in the essay type. In that case, the marks are varying actually. Okay?
Okay, sir.
Therefore, you need to understand these three very carefully. Definitely, you can expect a question from this one. Can be a MCQ, can be structured essay, or can be essay type. One of them will be there. Therefore, you need to understand it carefully. Okay?
Okay, sir.
මේ කොටස් තුනම හරියට මතක තියාගන්න. vertical allocation, linked allocation, index allocation. ඔය තුනෙන් එකක් විභාගයට අනිවාර්යයෙන්ම එනවා. You have to understand it carefully. Let's see each one. First one, vertical allocation. This is not difficult actually, very interesting lesson. This is not difficult, very interesting and useful lesson actually. The cases are not difficult, only thing to understand it. Because
Okay,
very
sir.
interesting, useful lesson actually. Now, the first one is contiguous allocation. Now, what is contiguous allocation? Now, we have the blocks in the hard disk like this. As I told you, we have the blocks in the hard disk like this. And we number these blocks as 0, 1, 2, 4, 5, 7, 8, 9, we number them. So we have the blocks here and this here we have numbers in the big bit. This is how you can see the blocks of the hard disk. Now, contiguous allocation means we store the starting block and some consecutive blocks will be allocated in the file. As an example, there's a file, let's say ICT.txt file. This is a file name. So in the directory, on the directory, we store this information. Directory, we store this one. This is the memory. We have the file name. This file name actually, and the start and the size. So start, let's say 0, 1, and 3 blocks. That means we store this information in the directory. We store this information, that is start. It says starting block is 0. How many blocks are there? 3 blocks. That means this first file has these 3 blocks. They are very consecutive blocks like this. That is called as in contiguous allocation.
Then, sir, why are we not taking third one?
No, this one needs only 3 blocks. They have to allocate only 3 blocks. These 3.
Sir, whenever we are drawing a block, we should number it from 0
Yes,
as
yes.
the starting.
Yeah, expand should be 0 in general. Then let's say we have another file. Another one we have text file. So what happens?
But in file management, you can't. No?
Let's say we start with third one and 2 blocks. Now what happens? The next file will start with 3 and 2 blocks. This is the first file. This is the first file. Okay. And second file will start with third and it has 2 blocks, these 2 blocks. So that is for. Okay.
I understand, sir. How, sir? Third and fourth.
I didn't understand the last one there, max.txt.
No, there is a second file.
Yeah.
Second file start with the block number 3. How many blocks we have? 2 blocks.
I understand, sir. How, sir?
No, we have just allocated like that. We allocate the second file, start with index number, block number 3, and let's say it gives a 2 blocks, and we added the 2 blocks line.
Okay, okay, sir.
Okay, sir.
That is for the contiguous blocks. We allocate always consecutive blocks, nearby blocks, always contiguous allocation. The contiguous box allocate. We allocate the nearby blocks together, consecutive blocks together will be allocated to the file. That is we call the contiguous allocation.
Okay, sir. Can you show me another example, sir?
Yeah. Now you can see this is actually if it has another file, let's say another one art.txt file. Let's say we allocate the block number 6 and again 2 blocks. So that means that file is starting the block number 6 and 2 blocks will be allocated. That means these 2 blocks will be allocated. So we assume we allocate 6 blocks. Start with the 6. How many blocks? 2 blocks will be allocated.
Okay, sir. If the size is third, then we should allocate 8 also.
Huh?
If the size is 3, then we should allocate 8 also, right?
Yeah, we can allocate the other blocks lines. Now the idea is that we want to allocate the consecutive blocks, nearby blocks together. This is called the contiguous allocation.
Okay, sir. Understood.
So we allocate the contiguous block, which is called the contiguous allocation. The directory is for the starting at the size. So then contiguous means we allocate consecutive blocks together, not here and there. That's called the contiguous allocation. We store the starting blocks and how many blocks are necessary will be stored here. So make it material and blocks allocate. Directory size directory. So that is called the contiguous allocation. Okay.
Okay, sir.
Now the problems. What are the problems here? There are many problems in this. Therefore, currently we don't use this one. Actually, this has some problem. One problem is file cannot grow. File cannot grow. That means some file can be extended. Now, if you take the first file, our first file has block 0, 1, 2. Let's say the first file is another block, no space, because third one is taken by another one. Is that clear?
Yes.
Because first file, we allocate the first 3 blocks. If the first file needs another block, you can't allocate because the third and fourth is only allocated to some other file. Therefore, file cannot grow. You can't extend the file size. So make it a major problem make a file extend the but we are passing it that. Issue file is that clear?
Yes,
Yes,
sir.
sir.
Huh? The second problem is this one has second problem, what is called external fragmentation. External fragmentation. Now, previously I explained you the internal fragmentation. I explained that internal fragmentation. Can you remember that internal fragmentation previously I explained? Internal fragmentation. Can you remember that?
Yes, sir.
Yes, sir.
Because we allocate the 4 blocks, but in the fourth one, 48 byte is not used. That is called the internal fragmentation.
Okay, sir.
Okay. Now we are saying there's another problem here, which is called the external fragmentation. Then make it our question here. External fragmentation. So what is the external fragmentation? Is this one. Now let's say this one also used directly. Now the block number 5, this block number 5, this one is free. This one is free. And 8 and 9 are also free. Then there are how many blocks are free? 3 blocks are free. Okay. Block number 5 is free, 8 is free, 9 is free. There are 3 blocks that are free. Okay.
Okay, sir.
So block number 5 I'm getting පාවිච්චි කරන්නේ නැහැ කවුරුවක්වත්. ඒක his. ඒවා ඉඳ තියෙනවා. Now assume I have a new file. New file. That file needs 3 blocks. 3 blocks. I have 3 blocks. 5, 8, 9. 3 blocks are free. The file needs, a new file needs 3 blocks. Can we allocate it?
Can't.
Can't. Why?
Can't,
Because
sir.
they are not contiguous. I cannot allocate it. Therefore, you
It's
can't
just another
allocate.
block.
So since they are not contiguous, you can't allocate them together, which is called as external fragmentation. Even I have 3 blocks, I cannot use the 3 blocks. Why? Because they are not nearby. They are not consecutive blocks. Therefore, if the contiguous allocation, you can't use those 3 blocks to allocate a file which needs 3 blocks. එතන කවුරු හරි කෙනෙක් blocks 3ක එකක් කිව්වොත් මේ තුන අපිට allocate කරන්න බෑ. මොකද ඒ තුන එක ළඟ නෙමෙයි තියෙන්නේ දැන් තැන්වල තියෙන්නේ. ඒතර ඒකට අපි කියනවා external fragmentation. ඒ කියන්නේ memory එක space එක තියෙනවා අපි පාවිච්චි කරන්න බෑ. Because they are not contiguous. So that we call as external fragmentation. පැහැදිලිද ඒක?
Yes, sir.
Yes, sir.
That's clear, ne?
Yes.
Yeah.
Yes.
So those are the 2 problems. Those are the 2 problems we have in the contiguous allocation. Okay.
Done, sir.
Yeah. Now let's see how do you solve this one using the indexed allocation, sorry, linked allocation. Now these 2 problems can be solved using the next one. Next one is what? Linked allocation. Let's see the linked allocation. How does it work? So මේ ප්‍රශ්න ටික විසඳනවා ඊළඟට. ඒකට අපි කියන්නේ linked allocation. ඒක linked allocation එකෙන් මේ තියෙන problems ටික solve කරනවා. So we have the blocks like this in the file. File like major blocks in Now in the directory, what we store, we have the file name and we have the start and the end. So we store the starting file and the end. Now let's see the first file name is IC.txt. We just say starting is 5, last one is 9. What do you mean by this? The first one, which is start the file, first one is which one, fifth one. So this says starting one is fifth one, that means this. And also speed. Once you go on fifth one, it tells you the next one. Let's say next one is 7. That says the next one is 7 one. That means 7. This. When you go to 7, it says when the next one is 12. That means next one is 12. When you go to the 12, it says where's the next one is 9. Next one is 9. Now you can see 9 is the last one, then you do the minus one here. It indicates as the last. That is for linked allocation. Now we have the link to the first one. When you do the first one, it tells you as the next one. When you do that, it tells you as the next one. Then you do the next one is this one. Then minus one is finished. End. This is we call as a linked allocation. So the make it
Sir, how does
yeah.
Sir, how does it knows the correct part to like 7 to 12 like that to copy?
Huh?
How did number 7, 12, and 9 came, sir?
Yeah, that is what we need to allocate the links. That means when you go to the first block, it tells you the next one is 7th one. When you go to 7th one, it tells the next one is 12th one. When you go to 12th one, the next one is the 9th one. 9th one is the last one. Minus one is there.
Then
That
we
is how
can
you
put,
link. Each block should be linked together. In that case, you don't need to allocate the continuous blocks. You can allocate the blocks here and there.
then we can put random number now, sir. Now if you put the fifth
Yeah,
block, if you
this
put
algorithm will
8 1,
find out which is free. Those free will be allocated. Because sometimes others may be allocated. Let's say this one is allocated to 5. This one is allocated to 5, like that. And this may be allocated to some 5, like this. When you find the free blocks, that will be linked. Either free block ke badala, either linked ke naam ke.
understood, sir. Then if the sixth one is blocked, we have to put 7.
Yeah, like that. We want to allocate what is the next free available.
Sir, for 7th block, if you put 11th, it's okay, no, sir?
Yeah, that's okay. That's okay. Even
Okay, sir.
the 10 also okay, like that. It doesn't matter the location. If there is something free, that will be allocated.
So if you put 9th one, it's wrong, no, sir?
So 9 you can't because 9 we have already allocated the other one.
Okay, sir.
So the previous problem can be solved. If can the file grow? Let's say this one is another block. Can we allocate?
What,
Yes
sir?
or no? Huh?
Can't, sir.
Why can't? Because if this one is another block, you can erase this one. And let's say you can put this as a parent, then you can point to this one. Then you make it minus one. You can have a new block. It doesn't matter the location.
Minus, sir, we can put no, sir.
Yeah.
Second method.
Yeah, file can grow. File can grow. Only thing is just in any. एक हज़ार की तरह की. यहाँ पर file can grow. The Excel के file की इधर पे नहीं है. But here we have space in anywhere. You can just get a link.
But sir, first method is easy, no, sir?
My problem is the file cannot grow. The first method. In the first one, continuous method, problem is file cannot grow at. But here the file can grow. Okay?
Okay, sir.
Is that clear?
Yes, sir.
So in this one, file can grow. Even there are no space, you can grow the file. We have just get a link. So make it a file like a come extend කරන්න පුළුවන්. So මේ -1 කියන තැනට ඊළඟ plot එකේ number එක දාලා අපිට link කරන්න පුළුවන්. So file එක නිකම්ම grow වෙනවා. Okay, then the first problem is solved. Now let's say the next one is this one is free, this one is free, and this one is free. If a file needs 3 blocks, can we allocate these 3 blocks?
Can
Yes, then we don't get the external fragmentation problem. What we have to do is we have to just get a link to first one, and put a link to this one, and put a link to this one. That's all. No external fragmentation problem. Okay?
Okay, sir.
Okay, sir.
There's no external fragmentation problem. So make the external fragmentation problem එකක් නැති වෙනවා. ඒක දැන් ඉස්සෙල්ලා කිව්ව ප්‍රශ්න දෙකම නැහැ. ෆයිල් කරලා draw කියන ප්‍රශ්නේ ඉන්නෙත් නැහැ. External fragmentation problem ගෙන්නෙත් නැහැ. Is it clear?
Yes, sir.
Done, sir.
Now the problem. This has a problem. This one has a problem. Remember, one problem is the axis must be sequential axis. Axis must be sequential. Why? Because you have to go to the first one, then you go to the second one, then you go to the third one, then you go to the fourth one. Like you have to go to sequentially one after the other. Because you don't know where the blocks are available. Only thing you can understand where the blocks are available when you read one by one. So therefore, access must be always sequential access. So material make it the file එකේ තියෙන තැන හොයාගන්න බෑ. හොයාගන්න ඉතින් එක රීඩ් කරලා ඉන්නවා. පුලින් ෆයිල් එකට යන්න ඕනේ. ඊළඟ දෙවෙනි එකට යන්න ඕනේ. ඊළඟ තුන්වෙනි එකට යන්න. මේ වගේ එකින් එක යන්න ඕනේ. එක පාර්ට් එක කියලා බ්ලොක් එක කොහොමද තියෙන්නේ කියලා හොයාගන්න බෑ. Therefore, this is slow because it is sequential access, not random access. Is it clear?
Yes, sir.
That is one problem. Second problem here is that if one block is damaged, if one block is damaged, all of the rest will be lost. That means now we go to the fifth one, read this one. Then you go to the seventh one, read this one. Well, let's say this one is unable to read. There's an error. There's an error. Then you can't find any of the others. Okay? If the one block is damaged, you can't find the rest of the wall. That is the main problem here we have. Okay? පැහැදිලිද? මාක එක බ්ලොක්
Okay,
එකක්
sir.
රීඩ් කරන්න බැරි නම් ඩැමේජ් වෙලා නම් එතනින් පස්සේ තියෙන ඔක්කොම බ්ලොක්ස් ටික හොයාගන්න බෑ කොහෙද තියෙන්නේ. That is one of the major issue with this one. In
If
the
one
link
blocks get damaged, others all will be corrupted.
No, if this one is damaged, then you don't know where is the next one. Others may be okay, others are not damaged, but you can't find where is the others.
Okay, sir.
Is it clear?
Yes, sir.
So that is the problem here we have. There are two problems. One is sequential access. Other one is the one block is damaged. You lost everything others. So මම මේක එක බ්ලොක් එකක් damage වුණොත් එතනින් පස්සේ තියෙන ඔක්කොම ටික හොයාගන්න බැරි වෙනවා. Is it clear the problem?
Yes, sir.
Then how to solve this one? Now in the previous one, we have the file cannot grow problem, and again the external fragmentation. Now those two problems are solved by this one, which is equal as what? Link allocation. The මුල්ම එකේදී මම දැන් contiguous selection ප්‍රශ්න දෙකක් තිබ්බා. එකක් file cannot grow file එක උත්තරන්න බැහැ විශාල කරන්න බැහැ ඊට මානවා. අනිත් එක external fragmentation. මේ දෙකම විසඳුවා මේ link allocation එකේ. file එකට grow වෙන්න පුළුවන් external fragmentation පුළුවන් එක නැති වෙනවා. හැබැයි මේකේ තියෙනවා තව problem දෙකක්. This is equal as the access must be always sequential access, and if one block is damaged, everything be lost. So මේකේ තියෙන ප්‍රශ්නේ තමයි ඔයාලට පැහැදිලි ඇති sequentially access කරන්න. ඒක එකක්. And the block of damage, you know, the passing opening. That's the problem. How to solve that one? Now the people were thinking to solve this problem actually. For that, people find a very simple solution, and which was used in the most of the operating systems. That is we call as file allocation table. File allocation. Or sometimes we call it a fact. Okay. The solution to this problem what we call file allocation table, or we call it a fact file allocation table. So, very simple solution. What do they do actually? They create this table and store this table in the memory. This table contains all the addresses that are necessary to access to this file. What do they do actually? They create a table in the memory and store this in the table, and it's very simple. This is very important. In past papers, there are many cases with fact file allocation table. File allocation table එකෙන් තමයි අර ප්‍රශ්න දෙක විසඳන්නේ. ඒතර මේක හරිම සරල දෙයක්. මේකෙන් විභාග ප්‍රශ්න තියෙනවා. මම ඔයාලට දැන් past papers කරලා අපි ගෙවුවාට පස්සේ past papers you get the cases for the fact file allocation table. මේක හරියට තේරුම් ගන්න මේ file allocation table එකෙන් ප්‍රශ්න තියෙන past papers. So what do they do? We take the block numbers. Here we have the block numbers. I just draw only 51 numbers, but assume it is there. So I just draw this one for the 6, 7, 8, 9, 10, 11, 10. But it started with 0. But it started with 0. It's the table. In the table, now here we know that starting block is 51. So then starting block is 51. But I'm going to find. When you go to 51, the next one is 7. The next one is 7. You write the 7. Then you go to 7. When you go to 7, it says the next one is 2. When you go to 12, it says the next one is 9. That's the last one. Then you keep this data in the table in the memory. So in that case, remember, I don't need to access sequentially one by one the blocks, because once I go to the memory, you can find all the locations. Therefore, you need to go to each block one by one. The block locations are stored in the memory. This is in the RAM. This is memory. Memory is very fast with compared to the hard disk, because these blocks are in the hard disk, which is very slow. No need to go to each block one by one to find the location. The location information you can get from the table in the memory. So, one පැහැදිලි නැති අරගේ sequentially access කරන්න ඕනේ hard disk එකේ. අපිට memory එකට ගිහිල්ලා තියෙන තැන ඔක්කොම හොයාගන්න පුළුවන් RAM එකේ. ඒක sequentially access කරන්න අවශ්‍ය නැහැ. අනිත් එක තමයි the other one is if the block is damaged, you lost everything in the previous one. But here, even the blocks are damaged, doesn't matter. Other block locations are available in the memory. From the memory, you can find out there are other blocks. Even the blocks are damaged, doesn't matter, because the block addresses are stored in the memory. So through the memory, you can find other block locations.
So why did you put 9 block -1?
Because now I have another 9. Sorry. I should be -1, 10. This has a point 10. This part 10. 10 part is a minus. 10 is mine. Yes. Is that clear?
Yes, sir.
Yes, sir.
So then remember, even the blocks are damaged, doesn't matter. If the blocks are damaged, you have to consider after the random people pay taking blocks will be indicated. It's our person they come is the make it.
Sir, would they ask us to draw the fact table?
Yes. That is the question most time we have. There are carefully the information. You have to draw the table like this.
Okay, sir.
Is that clear?
Yes, sir.
That is the second part. Then we just go to the third one. Third one is called as index allocation. That is also the solution to this problem. Okay. That is index allocation. So index allocation is this one. In the index allocation, what happened? We have the data blocks diagram. Block number 0, 1, 2, 3, 4, 5, 7, 8, 9, 10, like that. Here are the blocks for the file. Now in the directory, we store the file name and the index block. Let's say you file name 56 and index block, let's say fourth one. It says the fourth one is the index block. Fourth one is the index block. What happens when you go to the fourth one, which points to the other blocks? Let's say these are fourth blocks, and so that is. Now, when you go to the fourth blocks, what happens? It says as next one. First one is, let's say, block number 7. That means it indicates block number 7 is one of the block to the function. And let's say next one is block number 12. That means other blocks for this file is block number 12. Like this. And let's say next one is a block number 2. That means next one is a block number 2. This one. And next one is a block number 0. That means the next one is block number 6, like that. Once you go to the index block, you can find out what are the other blocks available. That is what to the index allocation. Okay, is it clear?
Yes, sir, but fourth one is like a sentinel, sir.
Huh?
Fourth block is like a sentinel, sir.
Fourth block is the index block. That you have index block is the index block you have pointers to the others. That's what to the index block.
Okay, sir.
Okay, so that is how it works. In the index block, once you go to the index block, you can find out all other blocks that has pointers to the others. Then you can find out where is the others once you go to the index block. This is called the indexed allocation. Okay.
Okay, sir.
Now, in this one, if I give a question, let's say block size is 512 bytes. Block size is 512 bytes. And block address need 16 bits. Block address needs 16 bits. What is the largest byte? Largest byte in index allocation. What's the largest file you can have in the index allocation? Now, what information you are given? The block size is given. So one block is how much? 112 bytes. One block is 112 bytes. That information is given. Now, when you take one address, now this one has the address. This is pointing to first block, and that is pointing to next second block. Like last one is pointing to the next block. Now you can see this address needs how many bits? 16 bits. One block is 512 bytes. This block address needs 16 bits. You ask him how much the largest file size that can be stored in the index allocation. So ultimately, the block size එක 512 bytes. Block address එක කරනවා කියලා තියෙන bits 16ක්. එහෙනම් මේකෙන් හදන්න පුළුවන් ලොකුම file එකේ size එක කොහොමද? Then how do you calculate it? Remember, address needs 16 bits. The 16 bits means you can calculate your byte. Remember, 16 bits means how many bytes? 16 bits means how many bytes? 2 bytes. Remember, 16 bits means 2 bytes. That means address needs 2 bytes. Then how many addresses you get if you count there is 1, 2, 3, 4 like that? How many addresses you get? 5 to L divided by 2. Then how many addresses you get? How many get 156? Get 156 pointers.
Also 16 bits, 2 bytes.
16 bits equal to how much? 2 bytes. Because 1 byte is 8 bits.
Sir.
1
Okay,
byte
sir.
is 8 bits. Then 16 bits means 2 bytes. Then how many pointers you can create? 5 divided by 2. 256 pointers you can create. Okay.
Okay, sir.
Then the 1 pointer contains 1 block. 1 block is how much? 5 bytes. Let's point to another block. That block is 0.12. Therefore, file size, largest file size will be how much? The largest file size will be 512 bytes multiplied by 256 because it is 256 pointers. Okay.
Also 256.
Huh?
512 bytes into 256.
Yeah, 512 bytes 1 by 256. Now, how do you calculate this one? You can write like 512. This two can write 2 into 120. Yeah, this two. Then this one is how much? 1020 into 120. 1024 bytes means 1 kilobyte. That means 5128 kilograms. Okay.
For me, 256 can't understand, sir, how it came.
Because here there are how many pointers you can 512 divided by 2, and address is 2 bytes. Then 512 divided by 2 is 256 pointers.
Okay. And
Then
128?
one pointer going to 1 block. 1 block is 512. Then how many such blocks? 512 into 256. Exactly.
Yes, sir.
මේකේ pointers තියෙනවා 256ක්. එක point එක block එකට point එක. එක block එක 512. 512 into 256. So 256 you can write as 2 into 120. Then 512 and 2 means 1024. 1024 points 1 kilobyte. That is 128 KB.
So 128 KB no, sir, not 29 no, sir.
128 kilobyte.
Okay, sir.
Those are the three methods: contiguous, linked, index location. Is it clear?
Okay, sir, done.
Yes, sir.
Okay, now let's see some questions in the papers.
Okay, sir.
As I told you, this is not a difficult one actually, easy lesson. But there are possible questions. Can you see?
Yes, sir.
Now this is the last year level paper question. Can you try? I just give you a few minutes.
Okay, sir.
Can you try it? It's not difficult actually.
Done, sir.
Okay. Now we are asking to find out the starting blocks. So there are two files actually. So the files they got here. Now they have given like this. Now directory, we know that in the directory what we have. So directory what we have the file name. And it's starting block. We are asking for each file 1 and file 2, what are the starting blocks? That's what we find. Then you can see now here the -1 is the last block. Minus the last block. You have to go backward actually. Now -1 is the last block. Then for the one file, the last block. Then one file last block is 102. That is not asking. But they have to find again. Yeah, starting blocks of particular again. Then 102 you can see that comes from this side. That is 100. When you go to the 100, it says go to 102. And then you can see 100 is called by this one here. 102. But you can see 104 is not available anywhere. Therefore, first one is time block is how much? 100. When you go to the 104, it says from the 100. When you 100, it says the next one is 100. That's 1 5. Then the answer is one block is 102. And the other one is last one is 106. You can see 106 is coming from this one. And 105 is coming from this. And 103 coming from this one. But 103 is not available anywhere. So that there should be 100. Okay. Is it clear?
Yes.
That is how you find the answer. Answer is 104 and 103 the starting blocks. Is it clear? That is the answer for the first part.
Okay, sir.
The second part, they are asking the problem of selecting the larger blocks. Now, I told you this block size is normally 512 bytes. Block size can be 512 bytes. Now, they are asking what is the disadvantage of selecting larger blocks and the smaller blocks size? I think that's the question. The question is asking the file allocation block size must be carefully chosen. Given one disadvantage is each selecting a small block and size the larger block size. Now, the problem here is actually selecting larger blocks. When you allocate the larger blocks, what is the problem?
File access slows down due to a larger chain.
Yeah, that is actually the main problem is that internal fragmentation.
Okay, sir.
Because now let's say if you allocate the 512, okay, if you allocate the 512 blocks, if let's say we use maximum, let's say we use only 1 byte, we use only 1 byte. How much is the wasting? 511. Okay, 511
Okay.
is wasting. Let's say the block size is now is the block size 512 bytes. Let's say the block size is 128 bytes. We use only 1 byte. How much wasting? 100 Internal
Then one
fragmentation
block
is
is
more here, but internal fragmentation is less here.
Yes.
Okay,
Okay, sir.
because you're making the internal fragmentation. In that case, in the 512 bytes block, if you use only 1 byte, 512 is wasting. But if the block size is 128, if you use only 1 byte, wasting is 127. The wasting is less actually.
Okay, sir. Sir, if I write like the internal fragmentation increase a small file but occupies a full large block, is it correct?
Yeah, only problem is their wasting is internal fragmentation will be increased when the file size is increased. Block
Okay, sir.
size is increased. The blockage size එක ලොකු වෙන මේ විද ප්‍රමාණය waste වෙන එක වැඩි වෙනවා. පැහැදිලිද?
Okay, sir.
If it is a smaller one, what happens?
There'll be space.
Yeah, for the one file, you need to allocate the more blocks. Okay, more blocks.
Okay.
In that case, you have to allocate more pointers. You have to allocate the more space for the pointers because you have to have the you have to explore the address for each one, pointers. Then you have to allocate the more pointers for each block, for each file. That will waste for the space for the pointers or address.
Okay, sir.
පැහැදිලිද?
okay, sir.
Let's see
Okay, sir.
next past paper question. Question 24. Can we try this?
Okay, sir.
Done, sir.
Okay. Now let's see. So I think there are these cases are not difficult. Easy question. Now, the first one, it says that each block of the disk is 512 bytes. That means block size 512 bytes. When the file size is 1959 bytes to store the file, how many allocated file would be wasted? That means 512. So 1959 to cover, you have to allocate 4 blocks. That means we have to allocate the 4 blocks. Okay. So that is we have to allocate 512 into 4. 8, 4, 2048. Then how much the file size?
1959.
1959. You can see wasting is how much?
Answer is 89.
3 means 8.
89, sir.
89.
That's
So wasting is 89.
89 bits.
Yes. Then you can see the answer is so answer is 89, first one. Okay.
Okay, sir.
Right. The second question is that the data of the average.py file is stored in the blocks 125, 150, 170 on a disk that uses the indexed allocation schema. In this allocation schema, what information is needed by the operating system to find the block of the file, of this file, blocks of this file? So it says that we have the data is stored in the block 100, 125, 150, 175. Those are the blocks. You are asking what information is needed by the operating system to find the blocks of the file. What information is necessary in the index allocation?
The index block number of the file.
Yes. Index block, what is the block number? Okay. Is that clear?
Yes, sir.
Then the next one is asking when contiguous allocation is compared with the index allocation, which one causes the external fragmentation of the disk?
The first allocation, sir. The content.
Contiguous allocation, no, index allocation has external fragmentation.
The contingency allocation.
Contiguous allocation, yes.
Allocation.
Contiguous allocation is the one where we have the external fragmentation. External fragmentation means blocks are available, but you can't use it because you allocate the contiguous blocks. That is called the external fragmentation. Can you remember it?
Yes, sir.
Yes. Those are the answers. Then this is 2023. Can you try it?
Okay, sir.
You can't see that one. This is the question. Can you try it?
Done, sir.
Okay, now this one, it says that it uses a block number 218 and 220 for the file. Okay, 218 and 220, one block is 4 kilobyte. So therefore, we are asking what is important is 218 is the one starting block. This is starting blocks. When you go there, it says the next one is 220. That is a point 220. That will be the last one. Therefore, important block to store the 280 starting blocks. Is that clear?
Yes, sir.
Now they are asking to use at the 219 also. Therefore, that apply this at 219 and create a point to that and make it minus. That's all. Okay.
The first one is 218. Second one answer is
When you go there, it says second one is 280. Now it says that is 119 also. Now we have to 219 and make it minus on the transfer. That is part 2. Is it clear?
okay, sir.
This one.
Done, sir.
Okay, now let's see that. So in this one, you can see the minus one is the last one. So then 202 comes from here. And 202, the 200 is come from this one. You can see 100.
It's like repeating now,
Yeah,
sir.
201 is pointed here. Then 203 is not pointed by anyone. 203 is not taken. So you can see starting should be 203. Okay? It's starting. Starting 203, then go to 1 into 200 and 202. Here. So it's
Starting is 203.
Starting is 203. Is it correct?
Yes,
Yes,
sir.
sir.
Hmm?
Yes, sir.
Starting now. Then how many blocks? 203 is one block. Okay. And 201 is another block for this file. And 200 is another block. 200 is one block, 201 is one block, 200 is another block, and 202 is another block. Then we have how many blocks? 4 blocks are there. One block is how much? 4 kilobytes. 4 into 4, 16.
16 KB.
Yes,
16
Kilobyte.
KB, sir.
yes. Therefore, answer is 203 and
203.
16 KB. Answer is third one, fourth one. Okay? පැහැදිලිද? පටන් ගන්න 203 file size is 16 KB. Fourth answer is the correct answer. Okay?
Sir, can you share me the question again, sir? Sir,
Yeah.
can you share me the question?
Yeah. Right.
Okay,
Yeah.
sir.
Now, this one, can you see that? Oh, yeah. Can you see the board now? The question. Answer
Okay,
is
sir,
fourth
done, sir.
answer. Fourth answer, is it correct?
Yes, sir.
Yes, sir.
Then the next one is explain how operating system could find the blocks of a file when the file are stored in a hard disk using the contiguous allocation and index allocation. In contiguous allocation, how do you find out the location of the file? What information are there in the directory?
The entry stores the starting block number and the length of the file.
Yes. What is starting and how many blocks are there?
Yes.
Then index allocation.
It stores the index number and the OS reads the index number which contains all the block address of the file.
Yes, that has the index block. What is the address of the index block? Once you go to the index blocks, you can find out the other blocks where are they available. Okay? කියන්නේ index block එකට ගියාම අපිට පුළුවන් අනිත් තැන් කොහෙද තියෙන්නේ කියලා හොයාගන්න. ඒතර අපිට තියෙන්නේ index block එක තමයි අවශ්‍ය වෙන්නේ ඒකෙදි.
But sir, they have given a hint now, sir.
Huh?
They have given a hint now, sir. Use of the entry.
Yeah. Directory entry means actually directory entry contains the index block. Once you go to the index block address, once you go to the index block, you can find out the other blocks. Where are the other blocks are available?
Okay, sir.
we discuss this one. Yeah, this one can you try?
Done, sir.
Okay, now in this question, you can see they have given the snapshot of the file location table. They are asking what's the address where we need to store the starting value, and then when you are going to make it 20 kilobytes, one block size is 5 kilobyte. Okay, one block size is 5 kilobyte. So you can see last one is 304. 304 comes here on this side. 0.4. 303.
4 kilobytes, one block size.
Huh?
4 kilobyte, one block size.
Kilobyte is one block size. Then you can see 303 is pointed by this one. And 300 is pointed by this. The starting address should be 301. So therefore, start that is what put out in the directory 301. Is that correct? Is
I
it
went
okay?
wrong, sir.
Sir, the starting should be 300, no?
Yes, sir, 300.
300. No. Starting is for 300. Starting is 301. Because 300 is inside this one.
How, sir, 301?
301 is start. You have to come to this one first. Then it says go to 300. Then 300 is equal to 3. And it goes to 4.
They are asking the block number, no, sir?
Yeah, starting blocks.
Ah,
Starting block is 301. Okay.
okay, sir.
Now, what are the blocks for this file? First one is 301. Okay. When you go to the next block is 300. Okay. When you go to 300, next one is 303. Okay. When you go to 306, go to 304. When one block is somewhat 4 kilobyte. Now, what's the file size now?
16 kilobyte.
Huh?
16 kilobyte.
Yes, 4 kilobyte into 4. That is somewhat 16 kilobyte now. Now they are saying you have to make it 20 kilobyte. That means another block should be allocated. Another block should be allocated. Then you ask them how to modify the table. You can say that 302 is free. Okay. Then I have to use that part. What should I do now? How do I change it? To add the other blocks. Because we have to make it 20 kilobyte, that means another block should be allocated. Then how do I do that? What changes should be done to the file allocation table? This one, how do I change it? How do I change it? So this one is 302 is free. We can put the 302 here. And then this will point to the 302. And that will be the last one. Make it minus. Okay.
Okay, sir.
Is that clear?
Yes, sir.
Okay. This is, have you done that 2021? No, right? Try this one.
Done, sir.
Okay. Now you are asking the directory entry. Eh? So again, we can trace back. You can see here, last one is -1. So that is some for 101. That is from this one. 101. So 101 is come to 100 from this. 100 is 103. So therefore 103 is not there. So it's starting is 103. Okay. Starting block is 103. And what blocks are going to be used? 103 is a one block. 100 is another block. 101 is another. Those are the
Then,
blocks.
sir, starting is 103. Starting number.
Huh?
Starting number is 103.
Yeah, 103. Three blocks are going to be used. Eh? Then point to be 12.
12 kilobyte.
Yeah, 12. Eh? So it should be answer is
Fourth one.
fourth one. Okay. Is that clear?
Yes, sir.
Yes, sir.
Yeah. This is 2019.
Sir, then the third question, Roman number 3.
Yes, there's another one. Sorry. When the linked allocation is used for the disk space allocation, each file needs to slightly more storage space than the contiguous allocation. Why is that?
Because the link allocation stores a box next to another which uses extra storage space.
Yes, we have to give the address of the next one. Eh? Address should be stored. To store the address, some space is necessary. That's the reason. Okay.
Okay.
But contiguous allocation, we don't store the address of the next one. Eh? We store only the starting and the how many blocks are there. Is it clear?
Yes, sir.
Yeah, this one. Right.
Done, sir.
Okay. First question, what is mean by contiguous file allocation? In that one, we allocate the consecutive blocks together. In the directory, we store the starting blocks and how many blocks are there for the file. පැහැදිලිද? ඒකෙදි කරන්නේ එක ළඟ blocks ටිකක් allocate කරනවා පටන් ගන්න එකයි කොච්චර blocks ප්‍රමාණයක් අවශ්‍යද කියන තමයි directory තියන්නේ. Then write down the one drawback of the contiguous allocation. One drawback is actually file cannot grow because no space after the last blocks or the external fragmentation. ඔය ප්‍රශ්න දෙක තමයි තියෙන්නේ. ෆයිල් එක ලොක් කරන්න බෑ, එක්ස්ටෙන්ඩ් කරන්න බෑ. මොකද ඊට පස්සේ ඉඳ නැති නිසා සහ external fragmentation. External fragmentation කියන්නේ ඉඳ තියෙනවා හැබැයි සම්බන්ධ කරන්න බෑ මොකද they are not contiguous. However, contiguous selection is feasible to store the set of files in the CD-ROM. Why? Why?
Because files are written once and never modified,
Yes,
so the
yes,
fragmentation
yes.
never
Because-
occurs and space always will be available for us.
Yes. Because in the ROM means read only, we don't write. Because we get the problem when I could write it, extend it. Otherwise, we don't get the problem. Last one, in addition to the normal data item, write down the other information that will be showing the linked allocation. What are the information?
The pointer will be next to a block
Yes.
of the file.
Next block pointer or the address will be stored. Yes. Yeah, those are the past application. Thank you for joining. Which is very easy lesson. I'll give the printed note next time. Before you.
Yes,
Okay,
sir.
sir.
Okay.
Okay, sir. Thank you, sir. Have a great day, sir.
Thank you, sir.
Okay. Thank you.